Have you ever wondered how your phone just knows how to finish your sentences? Or how translation apps can work in a split second? Well, it's not magic. It's all about memory. Today, we're diving into recurrent neural networks, or RNNs. This is the tech that first gave AI the power to remember what came before and to make really smart guesses about what's coming next. I mean, really think about that for a second. You're texting and your phone suggests the perfect next word. How on earth does it do that? It's definitely not just a random guess. It's looking at the context of everything you've already typed. It's remembering the sequence. And that little bit of everyday magic, that's a perfect example of an RNN in action. So here's the fundamental problem that a basic memoryless network has. It sees every word in total isolation. If it sees the phrase, "the cat sat on the," its guess for that last word is just based on general statistics, not this specific sentence. But a network with memory, or RNN, it's processed the whole sequence. It gets the context. It knows that Matt is a super likely answer. And in language, context is literally everything.
So, what is it that gives this network its memory? Well, the answer is this really clever piece of architecture called a feedback loop. You can think of this loop as the secret weapon that transforms a standard neural network into a recurrent neural network.
Okay, so an RNN is basically purpose-built for data that comes in a sequence. Its superpower is this internal memory, which we call a hidden state. It's kind of like the network's own working notepad. It lets it pass information from one step to the next. So it doesn't just see the word sat, its hidden state remembers that the word cat came right before it. And this process is a really simple but incredibly powerful loop. For every single word or item in a sequence, the RNN cycles through these steps. It takes in the input, checks its memory, gives an output, and then, and this is the most crucial part, it updates its memory with what it just learned before it moves on to the next thing. It's just this constant cycle of learning and remembering.
But, this basic memory, it's not perfect. It's a lot like our own short-term memory. It's great for the beginning of a short sentence, but what happens when you're dealing with a really long paragraph? Those important details from the very beginning start to fade away. And for an AI trying to grasp complex ideas, that is a huge, huge problem.
And this isn't just a metaphor. It's a very real technical hurdle called the vanishing gradient problem. Just think of the gradient as the signal for how important something is. As that information travels through a really long sequence, the signal gets weaker and weaker and weaker, kind of like a fading echo. And eventually, the network literally can't hear the crucial context from the beginning anymore, which makes it impossible to connect ideas over long distances. So to solve this, engineers came up with two really powerful upgrades, LSTMs and GRUs. The LSTM, or Long Short-Term Memory Network, is the powerhouse. It uses this sophisticated system of gates to carefully manage its memory. It basically learns what to remember, what to forget, and what new info is important enough to keep around. Then you have the GRU, which is more of a lightweight champ, a simpler, faster model that honestly often performs just as well. Now, this core idea of a memory loop is incredibly versatile. By reconfiguring it in different ways, we can create different architectures for all sorts of tasks. So it's really less of a single tool and more like a complete toolbox. First up, we've got the many-to-one architecture. This is perfect for things like sentiment analysis, where the network reads an entire sequence, say a long movie review, and then boils it all down to a single output, positive or negative. And of course, you can flip that right around for a one-to-many setup. In this case, the AI takes a single input, like a photo, and then generates a whole sequence of words to describe it. This is the magic behind automatic image captioning. And finally, we have the powerful many-to-many architecture. This is where the network transforms one sequence into a completely different one, taking a sentence in English, for example, and spitting out its translation in Spanish. This is really the foundation of modern machine translation. So all of this brings us to the big question. With all the buzz around these massive new models like transformers, are RNNs still relevant? Are they just a stepping stone from the past, or do they actually still have a place in the modern AI world? Well, the answer is, it's complicated. Transformers, which are the engines behind things like ChatGPT, are dominant right now because they can process an entire sequence all at once. That's called parallel processing. But RNNs, which go one step at a time, still have a really key advantage: efficiency. They are often way better for smaller datasets or for real-time applications, like analyzing streaming data, where you just can't wait for the whole sequence to be finished. Okay, so as we wrap up, let's just boil all of this down. What are the big things you really need to walk away with from all this? So, here are your key takeaways. First, and most importantly, RNNs were the breakthrough that gave AI a memory so it could understand sequences. Second, that basic memory was too short, so it got majorly upgraded with LSTM and GRU gates to manage information way better. Third, even with all the new models out there, they are still a powerful and efficient tool for a lot of jobs, especially with streaming data. And finally, you have to remember they paved the way for modern AI. They created the foundational ideas that models like transformers are built on today.
And that leaves us with a really fascinating thought to end on. We've actually built machines that can remember the past, to understand the present, and predict the future of a sequence. So the question is no longer just how they do it, but what should we ask them to do next?